Hey kids, this is Mr. Cozy and I'm here with the lecture off of video 45. This is something that I would normally teach in class, but since I'm not here this week, I'm going to record it as a video. And the thing I want to focus on in this video that I didn't I wasn't able to talk about in the proper video 45 is how to tell if a function is one-to-one from just looking at an equation. So let's start by looking at the elementary functions that we learned about a couple weeks ago. Here they are: square root, x cubed, x squared, cube root, linear, and absolute value. If you look at these 6 elementary functions, it should be clear which ones are not one-to-one. Like square root is one-to-one. X cubed is one-to-one. Cube root is also one-to-one, and just plain old x is one-to-one. The 2 functions that are not one-to-one is absolute value and x squared. So the first point I want to make is if you see an elementary function and it's x squared or absolute value, almost all of the time your answer is going to be not one-to-one. There's one exception that I will talk about at the end of the video, but your default move if you see quadratic or an absolute value is that it is not one-to-one. Okay? Now, if you see these other functions, it's tricky. None of the transformations that we learned change one-to-oneness. Okay? So if you're looking at the equation of a function, and here are several, and you can clearly pick out the transformations, then if the elementary function isn't one-to-one, or if the elementary function is one-to-one, the function that you're looking at is one-to-one. For example, let's look at 2x cubed, or 2 times x plus 3 cubed minus 2. We can pick out each transformation here. We have an expansion, we have a vertical shift, we have a horizontal shift. None of these change one-to-oneness. X cubed, the elementary function, is one-to-one, so this is also going to be one-to-one. Okay, ditto for 3x minus 1. This is a version of the linear function f of x equals x. This is one-to-one. We see an expansion here. We see a vertical shift here. Let me adjust this a little bit. These are not going to change one-to-oneness. This is one-to-one. Okay. Conversely, this is right away I see a quadratic. I can stop. I know this is not one-to-one because quadratics are in general not one-to-one. Absolute value, also not one-to-one. Okay. Cube root is one-to-one, and I'm looking at a vertical shift and a horizontal shift. Those do not change one-to-oneness. This is one-to-one. Okay. Now, let's take a look at this function. This is cubic. It's a cubic function. The biggest exponent is x to the 3rd power. It's 3rd degree. That's a cubic. But we cannot pick out the transformations that are happening here. They just aren't clear. And so this takes us to my second point, which is if you're not sure, graph it. Okay? Put the function in a grapher and see what you have. So let me pull out my calculator here. Now, just I'm going to kind of give you a spoiler here. If you graph any of these, you'll see that they are one-to-one or not. But this one, we're not going to know until we try to graph it. So I'm just going to go and turn it on, clear it out. I'm going to graph x cubed, x to the third power, minus 3x squared minus 10x plus 24. And guys, if you don't have a graphing calculator or you're not sure how to use it, just put this thing in Google. It'll show you a graph. Okay. Now I'm going to zoom standard. Let's take a look at this. And right away, I'm seeing that this is not one-to-one. It does not pass the horizontal line test. There's lots of places where a horizontal line touches the graph in more than one place. Okay, so this is not one-to-one. Now, the reason why, whoa, there we go, not one-to-one. Now, the reason why this cubic is not one-to-one and this cubic is the transformations that we learned are not the only ones that are possible. And the ones that we learned have the property that they do not change one-to-oneness. If the elementary function is one-to-one, expansions, contractions, reflections, and shifts do not change that. This last example here has not undergone those transformations, or it has, but it's also undergone other transformations, other stretches, other twists, and that makes it not one-to-one. Okay, and you can kind of see that comparing this graph. Let me zoom out just a little bit here. Let me go. Just go negative 20. Oops, come on, get up there, get up there, get up there. There we go. Negative 20 to 20 and negative 20 to 20. So I'm really zooming out, and let me turn off I'll put a mark every 5 notches. Okay, this should help us see the whole graph. There it is. Well, we see most of it. We see that this has that S shape that we saw in the elementary function, but the middle of the S has been distorted. This region has been pushed up. This region has been pushed down, and it made it not one-to-one. Okay, there are more transformations out there than just the ones that we learned. So if you're ever in doubt, graph the function, because it'll show you if it's not one-to-one. Okay. All right. One last thing, and then you can get to the assignment for the day. This is a quadratic. Okay. And by default, quadratics are not one-to-one, except this quadratic also has this little inequality here. And this inequality is called a domain restriction. And basically it limits what x's are eligible to plug into this particular function. Okay? So let's see what consequence that has. I'm just going to go and very quickly graph this out here. So let's start out with my, you know what, I'm just going to put it in the grapher. I think that's the fastest way to go. So I'm going to put this in the grapher. X minus 3 squared plus 1. I'm going to zoom standard, which is 10 by 10. And there's the graph. Okay, now this is clearly not one-to-one, but because of this domain restriction, we are not taking this whole graph. We are only taking x's. Let me get a snapshot of this here. Take a screenshot of the LCD with colors. There we go. Nope. Try that again. Take a screenshot of the LCD with colors to the clipboard. There we go. And then let me do a little pasty paste here. Home, paste. There we go. There's the graph. Let me lasso this. And let me blow it up. There we go. Okay, so here's the graph. We see the domain restriction. This function is only good for x's greater than 3. So what I'm going to do is I'm going to find 3 on the x-axis, and I'm going to draw a line, because I'm only taking this half of the graph, the half that is greater than -3. I'm ignoring everything that's less than positive 3. Sorry, positive 3. And as you can see, if I only look at the x's that are 3 and after, this is 1 to 1, even though it is quadratic. So this is a situation that we run into sometimes. Quadratics are not 1 to 1, but because they show up all of the time, it's very helpful if they are sometimes 1 to 1. So what mathematicians will do is they'll do a domain restriction to hone in on the chunk of the function that they want to look at, and then because of the restriction, it is 1 to 1, and they can do all sorts of things, such as safely take a square root. Okay, so that's that. I'm going to stop here, and I'll let you guys get to the assignment for the day. See ya.